Okay, it's time to take our quiz. And the first question is, a certain color of light is shining on a wall. A different color of light shines on the same wall and interferes with the first color of light constructively. Okay, now you're going to take yet a different color of light and you're going to shine it on the same wall, but this time it interferes destructively. So why would it happen this way? So it all comes down to the wavelength of the light. So let's say that we are going to mix the color green. So let's say that the color green has a wavelength that looks something like this. And it's going to shine onto a wall. So you notice that it's going up. Okay, now what we want to do is we're going to shine red light onto this wall and mix it with the green. So red light is going to have a wavelength that is larger than the color green. So that means that I need to draw it something like this. Okay, and notice this time that this one's going down when this one is going up. So that's going to be destructive interference. Okay, but let's say that we've got blue light, so these two canceled out, but what would happen if you had the green light and you're going to mix it, let's say, with blue? So blue light is going to have a wavelength that is shorter than the green. So that means I need to kind of draw it something like this. And so I'm going to draw it so that when this one's going up, then the other one's going up. So this one's going up at the same time this one's going up. And so this would be constructive if you added these two colors together, but it would be destructive if you added these two colors together. Question number 2. Under what circumstances will light diffract? So we need to remember, what is diffraction. So diffraction is going to be the bending of a wave when it goes around something. And so we showed how a wave, when it encounters a slit, is going to open up like this. So under what circumstances it is going to control how much it's going to open up. So it's going to depend on the wavelength of the light that's going through the hole, and it's also going to depend on the distance between that. So what's the size of the hole, and also what's the wavelength of light going through the hole, and then those things are going to determine how much it's going to bend when it goes through that hole. Question number 3. What is polarization? So light is polarized in that it has a electric field that is going up and down like this, and then it also has a magnetic field that is perpendicular to it, so it's sideways. So this is the magnetic field. So that's what light is. And light from the sun is unpolarized. So that means that some of the light coming from the sun has its electric field like this, some of it has its electric field like this, some like this, some like that, and so it has all sorts of different orientations to it. But when we run it through a polarizer, which is a piece of plastic that has the crystals in it that kind of make a picket fence, then what it will do is it's going to block all of those other polarizations except for the polarization that matches the polarizer. And so then we say the light is polarized once it goes through the polarizer. Okay, and then that's the principle behind polarizing sunglasses. Okay, so that is the last of our lectures on waves. So the next step is to take your unit exam over the waves. And so if you're one of my students, make sure and watch my review videos over all of this material. And if you're not one of my students, then don't bother to watch it, and just stay tuned for our next unit, which is going to be on motion. And so first, we're going to talk about Newton's first law of motion, and that will be our next video. So I will see you then.